Hello and welcome to a new video on Neil's Retro Hobby Room. Today I want to show you the final ATX64. I built the ATX64, which was designed by Matthias over the last half year, and today I finished building it. And it was a lot of fun, and I'm really happy that it works very well. The ATX64 is a Commodore 64 built on an ATX motherboard. And in the last videos, I built the main board, so I had to solder it by myself. I built a graphics card, which is really nice, and you can see the output of the graphics card here on the right side of me on the TV screen. I built a keyboard connector, and I built a hard drive controller, and I connected a 128 gigabytes SSD to the hard drive controller. And all this is in this nice case here. And this is a Cooler Master case with a Be Quiet power supply. Here you can see the graphics card. Here you can see the keyboard controller. And you can't see right now the hard drive controller and the hard drive. But later in this video, we will have a look into the case and I will describe more in detail what I have built. The build process was a lot of fun. I really like soldering. I had ups and downs. For instance, I had a problem with the graphics card, but that was my problem because I destroyed a trace, so I had to add a botch wire. And I also had a lot of fun when I built the hard drive controller. I found some hard drive controllers on the internet that were open hardware. And I ordered the first one, soldered it, and it didn't work at all. And then I found another one built by Jochen Adler. And this is a really nice controller and it worked very well and it still works very well. And also with the ATX64 mainboard, I had a lot of fun building or soldering it. But I have a few points that I want to address in this video to Matthias, who is the creator of that mainboard. First of all, the mainboard is great, but there are 2 or 3 things that I would like to change for future revisions. And if Matthias watches this video, maybe he can work on the mainboard and further improve this really brilliant mainboard that we have here. But at first, let's have a look inside the case and how I added all the components into the case. It was not very easy because some things were missing, so I had to improvise. Here we have a look directly inside the case, and we will have a look at each part in detail. First of all, the power supply. We have an Be Quiet power system power 9, which is connected here on the end to the main board. And one viewer of my channel suggested that I put the cable behind the main board, and that worked really well. In my last video, the cable was in the way of the board and I put the cable directly behind the board. Now let's have a look at the keyboard connector. The keyboard connector is here, this card. And there was a problem installing the keyboard connector, as you can probably see. I had to glue it with glue to the slot bracket, but that worked quite well. And I had to use a zip tie to further strengthen it or the connection so that when you put in the keyboard into the connector, that you don't have any problems. Then I used these 10 cables or 20 cables that go from the connector onto the board where you usually connect the C64 keyboard. So this allowed me to connect the keyboard connector to the board and put the keyboard connector at the back of the board. Now we have a look at the graphics card. The graphics card contains the VIC-2 chip and it contains special circuitry that allows me to connect it to a TV. And here you can see the connectors at the end. So on the most left side, you have the power connector. In the middle, you have the connector for the TV. Then the purple connector is for the keyboard. And here on the right side, you have connectors for audio on the right, topmost right side. Below that you have the power connector for my SD to IEC connector. In the middle you have a joystick connector, and on the middle you have a connector for the SD to IEC connector. Now let's have a look at the hard drive. The hard drive is here, and the hard drive is a 128 gigabytes Intenso hard drive, and I connected it using this red cable to my self-created hard drive controller that you can see here. And there's an adapter on that controller, and this adapter allows me to connect an SATA hard drive. And the connector I soldered by myself. As I said, it's an open hardware project that I found on the internet. And it's connected using this cable here directly to the main board here. This is also an IC connector. And this is everything that I built for the ATX64. I think it's a very beautiful machine in a very nice case. And now I think we could try to test a few games on that machine. But before we test some games, I want to first close the case using the glass of the side. At first, let's have a look at the SD to IEC card that I have connected. I have a connector for that is this here. And I can change the SD card here, put games and programs on it, and then load it directly from the SD card. But I can also use the internal hard drive. But first, let's have a look at the SD to IEC card. This works very well. It's connected to the backside of the ATX motherboard, and we could now, for instance, start a game. But we could also have a look at the hard drive. For the hard drive, we go to 30 for the ID 30. The hard drive is connected via this ID. Now we can make a list. And I also put a few games onto the hard drive. I put Pick and Mix from Shellen onto that hard drive. I think this is a really nice game, and we will have a look at this. This is a very early version that I downloaded from the GitHub, I think. And I put Montezuma onto that hard drive. And as you can see here, we have 119 gigabytes free space. So let's load Pick and Mix.prg from the hard drive. The game has been loaded, and now we can just run it. I will increase the sound a little. And I hope I have connected the right COM port. Yes, it looks nice. Here we have the game. I really love this. This has been created by Shellen on his Twitch stream with his viewers. And I hope that they will release this in the next month, I hope. Since this is, as I said, a very early stage. But I think it's just brilliant, and I love playing it. It has nice graphics, nice sound, and it works very well on my ATX64, as you can see. And now I died. And the game is over. So this works very well. And what else do I want to show you? I connected the reset switch here, so we can reset the system. This was a brand new game for the Commodore 64 running on the ATX64, but I think the ultimate test is always Giant Sisters, so I want to try this also. And this comes from the SD card. And here we have Giant Sisters. Also runs very well on my ATX64. And I just love this game. Let's just play the first level as fast as we can. So also old games work very well on the ATX64. So in conclusion, I really like to build this machine. I had a lot of fun. It is very well designed. So the ATX64 is a brilliant piece of hardware. It's easy to solder. Everything worked from the startup, so I didn't have any problems with the ATX64. But there are a few things I would like to address to Matthias, what I would like to change in the future. And there's one thing that was or is a little bit annoying with the board, and that is the way how the keyboard is connected to the board. You have these pins on the board where you can connect an original C64 keyboard to the main board. This really works very well. So for testing, this is really great. But when you want to connect when you build this machine, you don't want to connect an original C64 keyboard. It doesn't make any sense. You have this closed case here, and where should I put the original keyboard? So I want to or have to use an external keyboard like this one here. And it's really nice that you can connect the PS2 keyboard here using this small card that I built in one of my older videos. The problem with that card is that it's also located. When you build it, you put it on the middle of the main board. You probably saw this in my previous videos. And then you can connect the cable to a card sitting on the middle of the main board. That is, as I said, a little annoying. And usually you want to connect the keyboard directly to the main board. So one solution for the problem here is that Matthias could change the mainboard in a way that there is a PS2 connector directly on the mainboard, and then you connect your PS2 keyboard directly to the mainboard. I know he has to change the circuitry, he has to add some additional sockets, for instance, for the microcontroller responsible for the keyboard, and he has to find a place where to put the keyboard connector. And in my opinion, this should be at the position where the original PS2 connectors for the original keyboards, or for instance the usual PC mainboards are. And that could be a solution for the problem with the keyboard. Another solution would be to redesign that small card that we have to allow it to put it into a socket if possible. You have several sockets on the mainboard, the usual ATX the usual connectors where you put the cards into the board, and you could change the keyboard connector so that you can put it into such a slot. I know this could be a problem when not all signals that are needed for that card are available on that connector. So my third solution would be you can put it into a socket where it gains power and all the signals that are available in that socket, and you have additional connector on that card as we have it right now, where you can put the cable, as I did, from that card to the connector on the board. So in that way, Matthias has not to change the main board, but has to change the keyboard connector card. That would really ease my life, and I would not need to glue that small card that is not intended to be put into the ATX case onto a slot bracket as I have done right now. And that brings me to another problem that I have right now, and that probably others who created or built that board also had or will have. I have no brackets or slot brackets for my cards. So what did I do? I used slot brackets that I had in my spare bin. I drilled holes at the right positions through that slot brackets, and then I put the slot brackets into the ATX board. I put the card behind the slot bracket, and I, for instance, glued the keyboard connector onto that slot bracket, but I really don't like. And I used zip ties to hold it in place. This works quite well. It's not very beautiful. It's kind of ugly, but it works. But by the way, you can't see it right now, and you can only see it when you have a look at the back of the case. But I know that it's an ugly solution, and I don't like ugly solutions. So it would be nice if Matthias could provide the slot brackets. I know this is difficult because he has to create such slot brackets, for instance, 3D print them and then sell them. I recently saw in his store that he added additional components for the main boards, like the filter caps or the EMI caps. He added the socket for the PLA and so on. So he provides a lot of additional stuff for people who want to create the mainboard and have problems getting these things. I had problems also getting these. So it would be a nice addition, Matthias, if you offer slot brackets. If that is not possible because you can't produce them, or it's too difficult to produce them, or too costly, it would be at least nice if you could provide 3D models for that slot brackets that you for that cards that you created, that everyone else can 3D print these slot brackets. And this would also help to improve the overall system here, to make it more nice and to allow to put the cards really into that case. And yeah, I think these two things are the main concerns I have. No, there's a third small concern that I have, and that is that are the stacked cards on the back side of the main board. So you have all the connectors with PCBs stacked on each other. And this is really a tight fit. And in the beginning process of creating the board or building the board, I had the problem that there was a small short, and it's still, I think, in that on these cards. I had to remove a logic IC that is for filtering audio and video, for making reducing noise. So it's not very important. You can remove it. But when I put that IC, it's an LS logic chip, as I said, when you put it back into the board, I have these shorts on that board. So this was a problem. And the other problem is it's really tight fit in my case. And for instance, when I connect my SD to IC device here, I have to bend everything in the back a little. I don't like this. So what could be a solution for that? It's difficult. I mean, the board is designed this way and it's a very tight fit, as I said. So a solution could be to either remove one card, for instance, with the user port, which is not needed for instance, by me. The only problem I would have that I get power from the user port for the SD to IC device. Another idea could be to create a vertical PCB that you put in a slot bracket, in a special one at the end of the board, and then you have all connectors on that. But I don't know if this is possible. This could be also a solution. And yeah, that is the problem that I have with these connectors at the end of the board. And I also have a problem that I have nothing to put in front of the connectors. So there's no plate that covers the hole where the connectors are. But this is a small problem. All in all, I think this is a really great project. I really, as I said, love to build the board. And I already saw that there is a new revision of the board with a soft power switch. I also have a small PCB for a soft power switch for the board. I didn't install it since I usually switch off power when I don't use the machine, so I thought I don't need this. I like that I had the possibility to connect the reset port and the power switch here, and I just power it on. I reset it from time to time, and when I'm done, I just switch off the ATX power supply. But as I learned, the new board has a soft power switch possibility already implemented. So Matthias is still working on the board. I really like that. I really appreciate that. And maybe in the future, I will order a new board and then build a new version of the board. Yeah, and this is everything with that machine. I think in future videos, we will play some games. I will put this into my office room, and then I will connect it to my recording PC and maybe play some games, use some programs, and work and play with this machine. And yeah, this is everything I wanted to show you in this video. I hope you liked it. If yes, please give a thumbs up. Also, if you did not yet subscribe to this channel, I would be really happy if you do so. This really helps me to grow the channel, make it more popular, and to present all these nice things to more people. And in future videos, I will build a new Commodore 64. I have a brand new PCB for that. I have a lot of funny cards I want to build. I have a lot of bigger stuff I want to build, like the Pi Storm. I have everything for my Pi Storm here, maybe in one of the next videos. So you can expect a lot of new videos on this channel. So thank you very much for watching and see you in the next video.